friends, our project title is Bi-directional multiport DC-DC converter. By match members are I am A. Anugraha, Salina Devi, Govardhan and Supriya, and R. Chini Susan. The main abstract of our and objective of our project is that we need to give supply to the load bidirectionally, that is from source to load as well as from the load size. We are using a multiport bidirectional converter that has been earlier used for a fuel cell and a battery system to improve its transient response and also to ensure constant power output. We are using a PWM control of multi-active bridges. Here there are two ports. One is port A and port B. Port A is the supply port and port B is the load port. Port A will get supply from a solar panel and will be supplying the load. In case when port A fails, this port B, which was earlier charged from port A, will supply the load as well as it will charge port A. So when port B fails, A will supply the load as well as charge port B. This was the existing method. Here there are 4 bridges which conduct diagonally. Here this is a one port system. Hence when the source fails, the load cannot get continuous supply. But here in our existing method, we will be using load port also. We are in the existing method, we are using it as either a buck converter or boost converter. In a buck converter, we will step down the voltage, and in a boost converter, we will step up the voltage. And next is our block diagram. This is nothing but exaggerated explanation of our circuit diagram. This is our proposed method. Here, as you can see, port 1 is the source port, port 2 is the battery port, and port 3 is the load port. Port A will get supply from solar panel. So this port A will be supplying the load as well as charging port 2. So when port 1 fails, this battery port will be supplying the load as well as charging port 1. So if again the battery port fails, the supply port will be supplying the load and the battery port will be supplying the load. Hence we are having assurance of bidirectional supply. The advantages here being there is an energy storage port, we are using a multi-winding transformer, and centralized control is there by means of a microcontroller. This is the explanation for a proposed method. Here for port A there are 2 modes, one is positive and negative. In positive mode 1 and 4 thyristors will be conducting, and in negative mode 2 and 3 will be conducting. The same goes for port B operation, where in case of the battery port 1 and 4 will be conducting, and in negative mode 2 and 3 will be conducting. This is nothing but the mode of operation of port A, positive and negative, with the help of a simulation diagram. The applications of our project is automobile, standalone self-sufficient residential building, and hybrid electric vehicles. Thank you.